Whatever clothes I was in, I ran without any chappals to their room to see the last ball.
Okay.
Because at 30 of 30, I thought we lost. I went to sleep, no point watching. Then they were banging on my door.
Let's go.
Who's going to talk first?
The mic is towards the light, so make sure you don't cover that.
Computer down, someone else can take, and then that way you can be up here and
Put it
talk.
on the table.
Yeah.
Alright, so for the first story, we are discussing where the hare decided to take a nap, and so this is the story.
Right. So, firstly, we're talking about how the hare and the tortoise essentially they decide to race. And if we want to connect this to like the scientific method, let's say, we can call this a proposition. Then the race starts, which we can analyze. We can create the analogy to further the analogy, relate that to a solution process running.
And, and then from here, the hare takes an early lead. So when we're analyzing the data, we can see that the hare's speed would be increased. And this is due to the impulse force, which impulse force can be defined as a high acceleration, which is seen by the hare at the start. Impulse force can also be an impact. So, for example, we have in the top left corner this image of a bird striking an aircraft, and this is known as an impulse force due to the impact on the aircraft and the airframe.
When we see that the hare takes a break in the middle of the race, we can relate this to our process sort of adjusting to the incomplete trial. And in another relation to like Aerospace, we can sort of think about this in two ways, one of which being an error in the experiment, which we'll talk about later, but another one being the damping coefficient. So damping is the process of when a system slows down or goes to stagnation due to an outside or like sort of unbalanced influence. And the easiest way to think about this is in terms of like an oscillation sort of system where, let's say, for example, like you have a yo-yo and the yo-yo is just going up and down, but due to other forces acting on that system, such as like an air resistance or friction, those are essentially dampening the motion of the system, causing for the yo-yo to slow down. And we can kind of relate it to the hare in this case because the little nap that the hare wants to take is sort of a dampening force on his initial momentum.
And then as the hare takes a break, the tortoise passes the hare. And when we review the data in full, we can acknowledge that the tortoise has a slow but constant velocity, which in the end allows the tortoise to win, which is our solution. And so that is the slow and steady wins the race first part.
So I'm glad you're kind of explaining all the concepts also, like the damping and the impulse force, because that was the major part of the journey. One is the analogy and explaining why the analogy is right. The other is also to whatever new concepts you're introducing to showcase that you have some understanding of that concept.
So this is the second part of the story where he realizes his mistake and analyzes what he did wrong, and he asks for a rematch. And here he finds out that he had invalid assumptions, not particularly about the race, but about how he was going to finish the race. His thought was he was going to win easily. That was his invalid assumption, and he had a lack of verification and validation. So I want to stress on both of them here. Verification is something that has been done by others before and you take inspiration from. He did not do that, and validation is him checking himself that what is the result going to be. Now that he knows that he has validation that this is how the race goes, he is prepared to finish the race, to make sure of his mistakes and not make them next time. And the second thing is his overconfidence and wrong initial race conditions. So he was overconfident that, as I explained earlier, he was overconfident and he had the wrong initial race conditions because he thought that the tortoise is going to be much slower than him. He can easily win the race by doing nothing. Then the tortoise agrees in a methodological choice to race again, and they start racing like the solution, doing the solution again and process of running again.
So as Tulak mentioned, this time the hare does not take a break, where he adjusted his methodology, and so the experiment is going to have a different result. And so we want to take this in comparison to the previous slide. This time the hare is keeping that high and constant velocity throughout the race. And now, one thing we notice is that in certain versions, while they talk about the path being through the forest or whatever, sometimes it is also known as a curved path. Like even in this image you see, the path is quite curved. And so if we were modeling this in terms of dynamics, we actually talk about this in terms of curvilinear motion, as we have in the bottom right, where if we plot the axes that the hare is going on, as this curved path, it becomes easier to navigate as opposed to the tortoise going just as straight as possible. And of course the hare wins this time, showing that fast and reliable wins the race. We also have two planes here to basically describe just a real world example of this. So if we define the race just as a race where it's like they have a defined length that they have to pass, clearly F-22 Raptor will easily beat the Dreamliner, showing that the race goes beyond just your capabilities but also what your application is, where obviously the F-22 Raptor is more of a fighter jet while the Dreamliner is more of a commercial jet and has a heavier payload. Next slide.
Oh, I just want to add on that. Oh yeah, I just wanted to add on that some planes are designed for higher energy efficiency usage over a shorter period of time, which is kind of analogous to the hare expending more energy and going faster, whereas the tortoise, it goes slower, but it can go for a much longer time, and that's also exemplified by the two planes.
Okay, for the third part of the story, it's where the tortoise rethinks the course. It's an initial guess to iterate, but he hashes out the constraints more of the issue at hand, and he plays to his strengths. So he asks the hare for a rematch. That's the proposition. Hare agrees. Methodological choice. They race. Solution process running. And hare cannot complete the course due to the water. So the tortoise had played to his strengths and rewrote the race to his specialization. This is an error, a technical barrier to completion. And so the tortoise who can swim wins the solution. And in the aerospace world, this is similar to specialized vehicles such as space probes, vertical takeoff and landing vehicles, and then cargo planes.
Can you explain a little bit why those examples are appropriate for this?
So the tortoise might not be the best at running, but he is playing to his strengths, and so he's focusing on something that kind of ignores his weaknesses and has fully acknowledged all the constraints to the issue and was able to fully analyze the problem and create a solution that benefits him the most.
I was talking about these three examples you have at the end, the space probes, VTOL, and cargo.
So I think all these examples are just showing how certain aircraft are able to better perform in more extreme environments, as we have the space probe obviously being in space. We also had cargo planes having to endure a heavier load, and vertical takeoff lifts we'll actually talk about in a later slide. We'll talk about more real-life applications. So we'll go more into depth on these.
So one more thing that I'd like to add, I kind of see this story as imagine landing a passenger A380 on in the middle of the sea on an aircraft carrier, right? That's not gonna happen for that plane. But on the other hand, the F-18, that's its strength. It realized that strength, like the tortoise, and it can land much easily. So they're both playing to their strengths.
Okay, and so for the final story, This is kind of like the conclusion where many iterations have occurred, and in each iteration we're slightly changing like an independent variable like the participant or the course, and we're looking at the dependent variable, which is like the outcome, and then we're analyzing this data, and then by looking at this data, now we're deciding, oh, what is this data applicable for? So the hare and the tortoise see, oh, the hare has these strengths and the tortoise has these strengths. How can we utilize these best? And so they decide to work together, and you know, the key component of aerospace engineering is collaboration to use different people's weaknesses and strengths. And then so they're kind of peer reviewing each other because they're seeing where the faults in each person's abilities are. And now they're making a new trial, and they're using a prediction that the fastest time would be met if they race as a relay. And so this is their hypothesis. And so now the hare has the responsibility of running the ground portion of the race, and the tortoise has the responsibility of swimming the river portion of the race. And that's optimization. And this relates to aerospace because all of aerospace engineering is pretty much just a balancing act of, you know, how can I use these resources best? You know, what is my objective? And in this scenario, we're trying to figure out how to run the race the fastest, but this also comes with the trade-off of where the hare and the tortoise both are needed in the race. So in the previous iterations, we could just use like one of the subjects to complete the race, but now in order to optimize the speed, we have to use more resources, more individuals in order to get a quicker speed. And in the end, they find that the race is completed with the fastest time when they're both incorporated. And then so this is where the hypothesis is proven and turned into a scientific theory. And the hare and tortoise celebrate their victory. And so this is a mutually beneficial approach to solving the problem.
I guess just like one example that kind of comes to mind when thinking about this, it's like how when you want to like deploy something like a satellite in space, you're not just going to send up the satellite by itself. You need like a rocket or something to send it up. So that's sort of like the same sort of concept of needing two different things to essentially achieve the goal, because the satellite is not designed to go fly up to space. So you need that extra component.
That's as perfect as an analogy as you can get to. That's nice. Okay.
All right, so this is the alternative ending to the original story. It was actually created by a poet who read the first story. And in this one, we have the same initial conditions where the tortoise and the hare are both can be considered as idealized rigid bodies moving in space, and the condition that they're testing is their speed. So they have this proposition, they want to race each other, and in this adaptation, the hare again takes a nap in the middle, which can be considered like an error or like a dampening force, as I mentioned earlier. But in this adaptation, he wakes up just before the tortoise passes him and speeds off to the finish line, and he ends up winning the race anyways. So this has a very different experimental result compared to the original tale, even though the same objective things happened within the story. The hare still took a nap in the middle, but in one, the tortoise won because the hare did not wake up in time. So this kind of shows that in the engineering design process, you can have the exact same steps and the exact same initial assumptions and everything and achieve very, very different results at the end. And also, this also shows that within the same objects, or like, let's just say a plane that you're testing, you can have multiple test runs where the same system ends up performing in two very opposite effects. And so slow and steady might not always be the best solution to maximize speed. We see this as well. So fast and reliable is obviously the ideal, but fast and unreliable is not necessarily a bad thing. And one historical example that comes to mind is the Boeing 737 MAX tragedy, if you ever heard of the huge court case that went on. Basically, it was a plane that Boeing designed modeling off of the Boeing 737. It was the MAX version. And that plane was designed in a hurry, and they realized later on in the design process that the nose of that plane tended to pitch upwards. So they designed a computer system called MCAS to automatically lower the pitch angle of the plane, but it ended up overcorrecting itself in more cases that was needed, which resulted in 3 major crashes, and eventually the plane was grounded and the company got into a huge lawsuit. But the point is that MCAS system, it worked in 99% of cases, but not in that 1% where it overcorrected. So we can kind of see the same thing where you could have a system that works, you know, in very different ways for the same scenario.
I really appreciate that, going out of the way to look at an alternate ending and also bring in the parallels with the aerospace example.
Okay, so we mentioned a lot of real-world examples in the context of each specific story, but now let's take a holistic look at how these fables can relate to aerospace and dynamics overall. So one way we can think about it is the way that we solve dynamics problems in the first place can be applied in different ways, like the tortoise and the hare. So we have analytical solutions, a lot of what we're going to be covering in this class, where we use calculus to find an exact answer through our procedure, or we can now use computers and numerical methods to find not quite exact solutions, but approximate solutions to much more difficult problems. And in this way, you know, we can think of numerical methods sort of as the tortoise, because they took hundreds, thousands more years to develop than some of these traditional like calculus and analytical based methods. But in some ways, we need these numerical methods to find solutions to problems that are just not possible to solve otherwise. Like in the example of the fables, the river can only be crossed by the tortoise because it's simply too difficult. And then we can look at some other examples of aerospace systems.
So I'll talk about the teamwork aspect between subsystems. So as you can see down here, we have a Cessna 208 Caravan amphibian. So this is originally a Cessna plane that is meant for just fixed landing gear and runway landing. However, they have created it or added in boats to it, these floats, and made it amphibian. So these floats, if seen on a runway, have wheels that come off of it that allow it to both take off on land with a pavement runway, as well as take off on water with the water runways. So this is also seen again with the Bell Boeing V-22 Osprey. Not the most reliable plane, as many different news outlets have shown recently, but it can be seen here that it can land vertically. So as it takes off, it uses the propellers in similar to a helicopter motion, and then it will then tilt the rotors and allow it to have that vertical component. So it can be seen taking off regularly with the vertical component going off, or it can as well land vertically. So this is good, as shown in this example, for aircraft carriers, or it can be land on helipads in specific spots. But the main one that is the most similar to the hare and the tortoise example we have is the amphibian Cessna, because it both can be in the water very efficiently, and then it can also take off with land similar to the hare very efficiently. Whereas this cannot really land in water, it just lands on a boat on top of water. So, yes, so when we work in teams, we persevere, and ingenuity is key, because when we persevere together and when we work together, we are creating more revolutionary, more like complex ideas due to the different specialties from each person. So this comes together in that way.
And then just to all wrap it up, we talked previously about how satellites and rockets are different, but let's take a look at how together, when we work together, as shown in the fourth fable, we need to do that in order to achieve the mission itself. And not only do the tortoise and the hare stages of a satellite launch mission represent the fable itself, they also relate to dynamics, because the first stage of a rocket and an ion thruster powered payload that's going to travel throughout the solar system have very different dynamics profiles. They have very different mass, very different thrust, whereas the first stage has different boundary conditions of its dynamics problem, because it's launching out of the atmosphere and has to deal with a lot of drag and needs a lot of thrust and needs to carry a lot of weight with it. The final stage, the tortoise, is what's necessary to actually achieve the goal of the mission and to gather data far out in our solar system, because it needs to travel for a long time and can deal without some of those initial boundary conditions that we have in the Earth. So like Gracie said, this example brings together all of the lessons that we learned from these tortoise and the hare fables and shows not only how dynamics and aerospace applications interact together, but what we can learn going forward in the semester as a team as we have to learn to work together and succeed in this course. Thank you.
Really good job. Also, just wanted to know in terms of the sources of information from which you have gathered, and also how challenging it. Okay. Good.
Yeah. So on the next slide, so you see on the other alternative ending that Alisa talked about. We had a website called Atlas Obscura where we got that version from, and discussed all the different versions. We also did use ChatGPT again. This time we gave a longer prompt to detail exactly like what we want each episode to be, and it gave us a full summary of what the story was.
Can you also explain some of the challenges that you faced in terms of the information you gather, and the second in terms of an analogy, because all analogies, leave alone this, will have their limitations. So you can't carry that far enough, which is why it's similar to modeling. The real world and the model are different from each other. They can get as close as possible depending on how good your modeling is. Similarly, an analogy can only get as close as possible but never become the real thing, right? So in terms of some of the differences that you see between the hare and the tortoise story, any one of the 4 episodes, and in terms of the examples that you brought out, if you anybody can elaborate on those.
I think one thing I can say is that when we talk about aerospace engineering, obviously most of it, what we're talking about are transportation vehicles that operate in the air or in the atmosphere. When we're talking directly about the hare and the tortoise, the mode of transportation basically is not the same at all. Where it's mostly like you're on terrain, you're on ground, or if it's the river, you're going to be on the boat. And so that's why we included vertical takeoff lift, where it's more of you have the aircraft carrier and you have the plane. So it's less of like a more direct connection that we could have gotten.
I can speak a bit to the information gathering aspects and hurdles we faced. We were trying to figure out how to most effectively incorporate details into the slide in order to make it not too cluttered, but also have the main points that were necessary that we're going to create an analogy off of, and also be able to accurately describe each step as a part of the engineering process. So that's like one thing that we were thinking about when creating the slide deck. Another thing is regarding the analogies. Again, there's only so much we can relate a tortoise and a hare to rockets and jets. But I think it's more of like the steps within the process that both of them kind of overcame or took part of, that we're able to compare that pretty well to different real life examples as well. And and also kind of showing the different roles that they played within that experimentation process can also be very well related to different steps of like a rocket launch or something like that.
So I think particularly the story with the aerospace engineering field is not really relatable because as we talked about different examples here, like the F-18 and the Boeing 737. If we see both of them are fast vehicles, both of them can fly up to hundreds of nautical miles. And here, when we relate to that, we are looking at tortoise who on land is very slow. So it gives a wrong perception of us comparing, especially to the aerospace industry. Even, for example, if you look at another example that I kind of think of this as, imagine a rocket going into space and then in space, right? Going into space, we might think is slow, but the speed at which it's going out of space would be 5 times that. So it could also give you the wrong perception of the analogy.
I think one last thing, my opinion was that while we were able to find obviously like a ton of different examples that we could in general relate to different elements of the story, sometimes it was challenging to get the example to relate completely because some parts of the analogy, for example, the numerical methods versus analytical methods, one that I was talking about, each part of that analogy has elements of both the tortoise and the hare. Like solving problems using a computer can be faster because the computer does all the calculations, but also having to develop and program all of your code takes some additional time. So it's sort of not as black and white as the tortoise and the hare fables make it seem, especially in a complex field
In
like
particular, I
aerospace.
like that because we work a lot in our lab on analytical techniques, and this is always questioned in terms of most people in structures area are working on numerical techniques. And I think you brought it out very beautifully in terms of the advantages and disadvantages of both. Yeah. Anybody else? That's it. Yeah. Nafiz, you mentioned in passing about the fact that you had to improvise on your prompting. Can you elaborate a little more on that?
Yeah, so I obviously had experience in structural analysis where we did basically the same thing. We used ChatGPT to generate the different episodes. So what we did was, obviously, if you just tell ChatGPT to just tell you the story of the hare and the tortoise, it'll give you the first episode. Whereas if you want the other episodes, you just specifically say,
Okay, go ahead.
you just specifically mention the 3 other episodes and specifically what plot points you want in those episodes.
Okay. You guys have any questions? Yeah. You see the magnet for this?
It attached itself to the chair to your right.
Oh, okay. To my right?
Yeah.
This one?
On the leg. Underneath.
Thanks. So you guys have any questions? Sir Babu or Manju? Yeah, okay. Fine. Yes, Jeff, yeah.
Can we meet at 5 just before Saxman? And I'll straighten out what I split up. Okay, so 5 o'clock. Sorry about that.
No problem. Okay, thank you so much. Good job. No, I'll just use this for a while, the board.